Namaste friends, this is Vishwas Prabhakar Pitte. In my previous video, I promised that I will make a special video explaining hydrogen economy and how it is not a sustainable economy, and that is why this special video is being made for you all. In my previous video, I compared biofuels, then electric vehicle along with electron economy and hydrogen economy, and I have clearly said that automobiles should work on biofuel, electric vehicles should be only battery operated bicycles and tricycles, railway, tram and metro are only true electric vehicles and they should be electrified, and hydrogen economy is definitely not good. I explained quite well about biofuel and electric vehicles and electron economy in that video, and I told that I will make a special video on hydrogen economy because there is a lot of things to be discussed with, and that is why this special video is being made. So let us start. Hydrogen economy is actually a mirage. Way back in 1807, when IC engines were invented, they started working on peanut oil and even on hydrogen. Thereafter, directly in 1970, electrochemist John Ohm Bockris, he coined the term hydrogen economy for the first time. Remember, in 1970, when he was giving a lecture or he was discussing the matters with General Motors Technical Center people in Warren, Michigan. At that time, first time, this hydrogen economy word came out. Everybody were talking about it, but nothing happened. Yes, mainly because the petrochemical lobby came up very fast. IC engines were developed. It was convenient to use the petrochem products, oil and gas and everything. And of course, the climate change and global warming problem was not there. So it remained there itself, and petrochem lobby came up. The fact is, universe is filled with hydrogen. Almost 73% of the known and visible part of universe is filled with hydrogen. But still, we have not started thinking about it, and it was good. It so happened that climate change initiatives were taken seriously. Everybody decided to stop fossil fuel usage, and then they said that okay, what should be the alternative, and everybody remember hydrogen. Not everybody. Petrochemical lobby. That is because when electron economy came up, that means renewable energy came up, petrochem lobby understood that their days are over. And when electric vehicles were getting energized with the help of batteries or fuel cell, then they understood that we need to do something. Especially they thought that if petrochem product usage will stop, what should we do? So they decided that what if we remove the dirty part of petrochem and store it somewhere and only sell the clean part of petrochemical, and we can offer our product packed in a nice wrapper, and that wrapper is hydrogen. What happens? Petrochem lobby wanted their existence, so they decided to use the methane, that is natural gas, to remove C out of it, which was actual energy source till today, and they started thinking that we will market hydrogen as a hydrogen economy product. And they started using the term that when hydrogen burns, it gives nothing but clean water and no emission. And everybody started that, yes, everybody thought that yes, the romance will start and things will be very, very fine. One interesting thing happened. Renewable energy is actually against the petrochemical lobby, of course. However, renewable energy, immediately this lobby of renewable energy understood that the generation of renewable energy is not 24/7, and whenever power gets generated, there may not be a load. So they need to store the energy intermittently somewhere. And they also thought that what if this additional energy will be immediately used to manufacture hydrogen, store the hydrogen, and then next day use the hydrogen, and then hydrogen can be used as a good storage media. And hence renewable energy also started indirectly or directly supporting the petrochem lobby. And this is how this time hydrogen is everybody's matter of interest. The issue is renewable energy and petrochem energy now joined their hands together, and hydrogen economy is thinking of getting ahead because of this only. Okay, so let us see really how this economy is. The fact is, if you really see what are the existing applications of hydrogen. So if we see this, I have clearly narrated in this table that hydrogen, almost 60% consumption of hydrogen is required for production of diesel in petrochem refinery itself. So all the diesel which is till date getting manufactured was because of hydrogen. Then 30% of hydrogen is being used to manufacture ammonia, which is required for every chemical fertilizer. So till date, whatever ammonia we were getting, hydrogen was being used for manufacturing ammonia. And third usage is, which is 10% of the total consumption, is to manufacture synthetic hydrocarbons, namely various fuels and used in chemical market. So frankly speaking, hydrogen was till date, hydrogen is being used as a chemical and not as an energy. And as I said that 60, 30 and 10, 100% market, the breakup is given. You can see that it is being used only as a chemical, and now we are planning to use it as energy. Now, what is the meaning of hydrogen economy? Hydrogen economy means hydrogen shall replace all types of fossil fuel for all types of applications eventually. That means it is expected that we should stop using petrol, diesel, coal, all CO2 emitting matters, and instead let us use hydrogen. That is the meaning of hydrogen economy. Now, it's good to say, but the fact is, how will you manufacture hydrogen and what are the current practices of hydrogen manufacturing? So here you can very well see that natural gas is the basic feedstock of manufacturing hydrogen. Here, with the help of steam methane reformation process, we manufacture 48% of global consumption of hydrogen. That means the majority input of raw material is nothing but natural gas, and that is methane, which is the outcome of petrochemical lobby. Then we can use oil. With the help of pyrolysis, we can generate syngas or producer gas, which is a mixture of hydrogen, CO2, and this is how we can separate hydrogen out of it and we can use it. This is about 30% of the actual production of total global production. Then coal. There is a lot of coal on earth, and what happens is when the actual mining of coal becomes difficult, and when coal seams go deep down inside the earth, cutting the coal, bringing it up on the surface and transporting it and using it becomes difficult. Instead of that, what if we convert coal inside the mine there itself in the form of methane? Then that process is called coal gasification, where either methane is getting formed or again synthetic synthesized gas, that is CO2 and mixture of hydrogen is getting formed, and then we bring that gas on the surface and remove hydrogen out of it, and that makes about 18% of today's global hydrogen production. And of course, fourth is electrolyzer. We all learned in our college or school that if you put electrodes in clean water and pass electricity, then you will get hydrogen on cathode, oxygen on anode, and that is called electrolysis, and that is about 4% of the total global production of hydrogen. So today these four processes are prevalent. Majority is steam methane reformation, and the major raw material which is used today for manufacturing hydrogen is nothing but methane, and that is CH4. Carbon dioxide can be separated from natural gas with 70 to 85% efficiency for hydrogen production, and from other hydrocarbons to varying degrees of efficiency. So the fact is, currently hydrocarbons are only being used to manufacture hydrogen, and that is what is very interesting thing. Now I will simply show you the actual mass balance of manufacturing process. Please study this process very clearly, where feedstock is CH4, that is natural gas, which is CH4. Then with the help of electricity, which is either generated through renewable or maybe a grid electricity, which consists of course CO2 emitting kind of electricity, and then we separate C from H. We get one particle of C, four particles of hydrogen. C is getting converted into CO2, and we get pure hydrogen. Now in this particular mass balance, you can see that there is still CO2 generation from the power plant if it is not renewable. Majority of them are not renewable, and of course the smoking chimney of hydrogen manufacturing shed itself. So currently the manufacturing process of hydrogen itself is a polluting process, and we simply remove that CO2, keep it with us or emit in the atmosphere, collect the hydrogen, sell it nicely, and we say that hydrogen economy is a clean economy, which itself is a misnomer, misleading or clear-cut cheating. The real insight over here is that carbon stripped from CH4 to recover hydrogen is actually the real energy. Till date, we were using this C, carbon, as the actual form of energy. We never considered hydrogen part, which we were actually burning with the methane, as part of energy. Now the majority part of CH4, that is C, we are simply destroying. In absence of that, what happens that we get less energy in our hand, and to support the equal amount of generation of energy, we take more methane as a feedstock. That means if we generate CH4 directly, and if you get an energy of X amount, now if you generate hydrogen out of it and still you want X amount of energy, you need to burn more hydrogen. To burn more hydrogen, you need to generate more hydrogen. For that you require more methane input, and that is 40% more methane is required, and hence this is the real attraction for fossil fuel lobby to sell their natural gas as feedstock. So they are very happy to give you energy instead of X amount of methane which they were giving you. Now they will give you 1.4x methane. That means their sale will shoot up like anything. And this is the real mathematics of generation of hydrogen and developing hydrogen economy. That is why fossil fuel lobby is behind this. And of course, as a climate change initiative, this H2 can be presented as eco-friendly fuel. Now, nobody is talking about what is the C they are doing. They are of course converting C into CO2. Now, if they are using renewable energy, then at least they can say that there is no CO2 generation for power plant. But what is the CO2 which is getting generated from hydrogen manufacturing shed itself? That is actually getting released in the atmosphere. Nobody is talking about that. So what happens that hydrogen manufacturing itself is not pollution free. What is said that the methane, when it is getting generated from the land, till you pipe it, bring it to the processing plant, then petrochem, upstream, downstream, all those, their standard terminology. What is being said and declared by experts that till date, fugitive emissions of CH4, that means leakage of methane, right from the point of generation till manufacturing hydrogen, till today or every year, the leakage of methane, this CO2 or the climate change problem which are getting generated by methane itself is creating their own carbon footprint, and this carbon footprint is actually bigger than the entire carbon footprint of Europe itself. Have you understood this point? Fugitive emissions of methane from source to H2 via hydrogen method is more than total carbon footprint of entire Europe. In fact, I should say the fugitive emissions of CH from some source of entire oil and natural gas lobby today is bigger than the footprint of entire Europe. This is very important fact. Now CO2 emissions are bound to happen as carbon capture and storage is not yet established. Frankly speaking, H2 supporters are saying that released CO2 will be stored with the help of CCS, that means carbon capture and storage technologies, and let me tell you frankly that such technology does not exist at all. So that itself is a problem. Then CCS, that is carbon capture, if at all it will be there, nobody will do it unless they will get paid for it. So without getting payment, CCS, carbon capture and storage, is a myth and it is not going to happen. So pollution is bound to happen because first there is no money in cleaning that pollution and there are no technologies exist for that. Then if you really see that today the manufacturing of grey hydrogen globally is generating so much CO2 that the emissions are almost like total emissions generated by aviation sector. The production of hydrogen through steam methane reforming produces emissions that are known to be harmful. It includes NOx, particulate matter, carbon monoxide, volatile organic compounds. So when we say there will be no CO2 generation, in fact it generates CO2 at all. At the same time it generates NOx, volatile organic compound, everything. And this is known to the hydrogen manufacturing lobby, and that is why very shrewdly they color coded the hydrogen, giving us as if they are doing it very professionally and very scientifically. Typically, see this chart in which you can very well see that there are total 9 and recently 10th number is also added, that 10 different types of colors are given to hydrogen depending on the process and the emission which they create. The first is of course green hydrogen. Green hydrogen is manufactured with the help of process called water electrolysis, where electrolyzers are required. Renewable electricity generated and no CO2 generation happens, which is practically correct, because if you are using renewable energy, electricity will not generate CO2, and if you are using water electrolysis, there will be no CO2 generation. So technically this is really green. This is manufactured almost to the extent of nil amount. Almost all or majority of the hydrogen which is getting manufactured today is a grey hydrogen, which is explained that the grey hydrogen is manufactured by using methane with the help of steam methane reformation and releasing CO2 in the atmosphere without any carbon capture, and that is why it is called grey. If you capture the carbon from grey methane, then it is called blue hydrogen. This kind of technology is not yet exist. Then there is a black and brown, where bituminous or lignite coal gasification process is used. Renewable or maybe fossil electricity is used. CO2 emissions are bound to happen in this case. In turquoise hydrogen, thermal splitting of methane with the help of pyrolysis is done. Renewable or fossil energy can be used, and Here it is said that CO2 is captured in solid form, but it is to its very minimum extent. Purple hydrogen, chemothermal electrolysis of water, and here the nuclear power is being used, and in this particular case there is no CO2 generation. That is because we are going to use electrolysis as a process. Pink hydrogen, it is again water electrolysis, but nuclear power is used, no CO2 generation. Red hydrogen, it talks about very high temperature generated with the help of nuclear power, and then water is split and there is no CO2 generation. And there is a white hydrogen, that means it is a naturally occurring hydrogen which is very rare, but it is a given name white hydrogen. And recently they named yellow hydrogen. It is hydrogen which was generated or which is generated with the help of electrolysis process by using solar energy. Now you can see that 94 million tons of grey hydrogen is currently produced globally using fossil fuel as of 2022, primarily natural gas, and therefore a significant source of greenhouse gas emission itself, containing energy equal to about 2.5% of global final energy consumption. So this 94 million tons of hydrogen is actually nothing but just 2.5% of the total global energy requirement. Now China is currently the largest producer of hydrogen, which is about 33 million tons a year, and bulk of that produced from fossil fuel. That means it is grey hydrogen. Again, United States of America, 10 million tons of hydrogen they require, 99% of it is from fossil fuel through steam methane reforming grey hydrogen. While industry touts hydrogen as a clean solution, globally only 0.02% of current hydrogen production is through electrolysis, and that is green. So that is almost up to nil extent. Now, as I stated to you that grey hydrogen, that is hydrogen manufacturing process basically itself is a polluting, and that is why they say okay, then we will capture the CO2 generated and we will store it somewhere and we will market it as a clean fuel, and it is called blue hydrogen. But that blue hydrogen itself is also not climate friendly as per the expert. The greenhouse gas footprint of blue hydrogen is more than 20% greater than burning natural gas or coal for heat, and some 60% greater than burning diesel oil for heat, due to higher requirement of CH4 for CCS. What it means that even if we manufacture blue hydrogen by carbon capture method, that means by doing all possible ways of stopping CO2 emission, the problem is to stop the CO2 emission, the technologies which is being used, that is carbon capture technologies, itself require a lot of energy, and for that energy they themselves require more additional CH4. This additional CH4 releases more fugitive emissions of CH4, and hence entire process becomes positively emitting process, and it doesn't remain green, neither blue, in fact it becomes black. Now, using hydrogen made from gas with or without carbon capture at a power plant actually produces more emission than burning gas alone at that power plant, due to the emissions intensity of creating blue or grey hydrogen. So this is quite obvious that earlier CH4 is being used in a distributed manner by every consumer. Now you are not giving CH4, that is methane, to every consumer. We are centralizing it, burning it in a central factory or a shed. Definitely emissions are going to be centralized and emission density increases like never before. That is the problem. Recent research also indicates that producing blue hydrogen does not actually reduce climate emissions compared to using methane gas. Now these are the facts. So blue hydrogen is not climate friendly. That means grey hydrogen is definitely not climate friendly. Blue hydrogen, as stated, never turned out to be climate friendly. Now, if this is the case, Fine. This is about processes. Now let us check the candidate itself, that is hydrogen. Somehow we manufacture clean hydrogen. What is the status of hydrogen? Hydrogen itself pollutes. Don't get surprised. The fact is, hydrogen leakage is actually 5 times more dangerous than CO2 leakage. Hydrogen is nothing but just single proton. In the periodic table, if you see, number 1 element is hydrogen because it is the known lightest element. What is hydrogen? Nothing but a single proton. So the size is so small that from wherever you transfer it, maybe through pipeline, maybe through pressurized vessel or a storage tank, it leaks somehow, it escapes. And hydrogen is known as indirect green gas because it combines with other compounds in that atmosphere to cause warming that is 5 times more potent than carbon dioxide over 100 years lifetime. That means hydrogen itself pollutes and it is 5 times more dangerous than CO2 leakage. No one tells you this because today climate change is being measured in terms of CO2, not in terms of any other polluting material. Why they say nuclear energy is clean? Because nuclear energy never generates any CO2 emission. But they don't say that nuclear energy generates radiation. Nuclear radiations are totally different than any climate change initiative and they are more dangerous. Nobody says that. Similarly, here in hydrogen, there is no CO2 leakage, but hydrogen itself creates tremendous trouble. No one talks about it. When hydrogen is combusted, though it does not produce carbon dioxide, but it does produce NOx, that means nitrous oxides and NOx compound, up to 6 times worse than those released by methane combustion. Now, NOx itself is a great pollutant. So, how can we say that hydrogen is not polluting? Now, okay, we'll go very logically. So far, I told you about hydrogen production processes are not eco-friendly. The types of hydrogens are not eco-friendly, that means green, blue, grey. The product itself, hydrogen, is not eco-friendly. Now, suppose we take that hydrogen, what are the next issues? Now, when you have a hydrogen in your hand, first thing is transport. Hydrogen transport through piping is itself a great issue. This is because so far, if you really see, there are 3 million kilometers long, million miles of methane pipelines are there. 96% of existing methane gas transmission pipelines are which are there in United States are made up of steel, and those are not suitable for transporting any hydrogen. That is because hydrogen is so small that it escapes through tiny, small, negligible crevices or anomalies or cracks which are already there in every pipeline, right from the manufacturing process, installation of the pipeline, joining the pipes together, and hydrogen escapes somehow. Hydrogen is so tiny that it goes within the molecular structure of steel or cast steel itself and makes that steel very brittle. This is dangerous. As a result, after some time, pipe itself breaks, and that is very dangerous. This makes nearly all of the current transmission pipelines in US unsafe for transporting hydrogen at all. Researchers estimated that hydrogen can only comprise 20% of volume of existing methane. Then only you can somehow transport through the existing pipeline, and which is nothing but just 7% of the energy. So we are not going to get the great benefit of using same pipeline in which instead of sending entire hydrogen, suppose we mix it with methane with just 20%, you are not going to energize the mix that much to get more profit. Safe transportation of hydrogen requires either plastic pipeline with a coating and those are currently rare. There are only distribution pipelines which are going directly to the home or to the actual consumption point. They are plastic pipelines, and the actual length of those pipeline compared to the actual requirement is almost negligible. Yes, there are some 1600 miles of purely hydrogen carrying pipelines in US, but they are on the Mexican coast itself, and you can see in US there are 3 million miles of methane pipeline. Compare that with 1600 miles of hydrogen pipeline. So you can see that a lot of job needs to be done, rather all pipeline needs to be replaced. Do you really think it is necessary? Okay, now transporting hydrogen through pipe itself is an issue the way I explained. What if we transport by compressing? Compressing, the energy density of hydrogen is quite small, and you cannot compress it the way we can compress LPG, and the net result is, suppose there is a diesel or a petrol pump and you want to start a hydrogen pump. Now, in order to fill that hydrogen pump with the equivalent energy of one diesel truck, you need to send 18 trucks of hydrogen. That is because one diesel truck equivalent of hydrogen can be transported, or it requires 18 trucks. So who is going to pay for additional 17 those trucks? This is because hydrogen is light, you cannot compress it to that level, and you have the volume of the storage is more, and here it seems that it is 18 times more. Is it going to be economical? Just to give you a perspective that hydrogen filling, the pressure of filling is 14 times pressure in comparison with LPG tank. It is 2 times pressure in comparison with scuba tank, which we use underwater. Now, hydrogen actually holds 3 times more energy than gasoline, but same amount of energy, the storage tank for hydrogen requirement is 12 times large. So, how your vehicle will look if you have to have a 12 times large storage tank. In a nutshell, pipeline transport of hydrogen is difficult. Compressing and transporting it physically with the help of truck itself is an issue. So, what exactly you want to do? Now the third thing is, somehow you transported it, or you want to generate it in situ. Hydrogen storage itself is very difficult. This is because hydrogen is less dense than gas, which makes it particularly hard to store. Gas means methane gas. Hydrogen can be stored in bulk in salt caverns, which are limited to a few locations in certain geographies only. So this can't be a standardized and man-made solution. For long-term storage, hydrogen must be converted to a liquid, a process which can be more expensive than producing the hydrogen itself. So liquefaction of hydrogen is again difficult issue. When storing liquid hydrogen, even if you make it somehow, some gas must be allowed to evaporate for safety reasons, meaning that after 2 weeks, a car would lose half of its fuel even when not being driven. This is very important point for those who are going to purchase hydrogen cars. Even if you store it in some tank, that you need to make an arrangement for evaporation of that particular hydrogen to make the entire storage safe. This itself is a negative fact in case of hydrogen. If hydrogen were to replace methane gas in the global economy, we require 3 to 4 times more storage infrastructure at a cost of $637 billion by 2050 to provide the same level of energy security as the world would have with gas today. So this is going to be nothing but new business, and that may be the reason why everybody is taking interest in it without knowing its sustainability. Some projects propose converting hydrogen to liquid ammonia for storage and transportation, and then converting this ammonia back to hydrogen at the site of power generation. The energy for this process is about equal to that of cooling and liquefying hydrogen, but far more infrastructure is needed to do that. And this is nothing but an effort to justify your efforts to bring hydrogen economy by involving so many stages of hydrogen transfer from one stage to the another, then bringing it to some other stage, then making it back to the original stage. You are going to lose a lot, that is the product hydrogen itself as well as energy. Rather, the 1/4 efficiency is based on necessary process of hydrogen economy and the properties of hydrogen itself, its low density and extremely low boiling point, which increase the energy cost of compression or liquefaction and the investment cost of storage. This is quite obvious. The energy density is small, and as a result liquefaction itself takes a lot of money, so investments are bound to be more. Now this is the issue which I am linearly stating you right from the formation, then the product itself, then gray, blue, green hydrogen issues, hydrogen itself is polluting, then the transportation, storage itself is difficult. Now let us consider, suppose we use hydrogen for specific application. So what type of application generally we see for any energy? So energy is required for building heating. Suppose we use hydrogen for building heating. Have you ever done the calculations? The calculations simply say that existing gas appliances can only handle hydrogen blending of 5 to 20% by volume, which severely limits the potential for emissions reduction. That means entire household cooking and building application apparatuses itself needs total replacement, because current apparatuses are just 5 to 20% by volume hydrogen they can take. Hydrogen used in building beyond that level would require all new appliances. Hydrogen is extremely flammable and catch fire even in small concentrations. Hydrogen itself is a clean fuel. If it catches fire, you can't see even the flame. It is a colorless flame. The fire is completely colorless, and it has happened at some places of the world itself that people inadvertently walked inside the fire of hydrogen and got themselves severely burned because they could not see that there is a fire. It is so clean gas, and that is why it is dangerous. Then hydrogen were used in home if to replace the methane gas, the annual predicted number of explosions is expected to be more than 4 times than what we are facing today. So there is a risk of human life hazard as well as insurance losses. If we check the heat applications, we can see that if we use electricity via heat pump, then 100 kilowatt of electricity can give us 300 kilowatt thermal output. Whereas if we use hydrogen through boiler, 100 kilowatt electricity can give 50 kilowatt thermal. That means if we generate if we want to use similar amount of hydrogen, then you will generate just 50 kilowatt thermal electricity. That means electricity is 6 times more efficient for giving you heat energy than burning hydrogen itself. Hydrogen boiler requires 6 times more renewable energy only because of this. If this is the case, why are we promoting hydrogen? Now, heat applications is unviable. Calculation shows that it is actually meaningless. What if we use hydrogen for generating electricity, that is power generation? Now see, the funny concept, electricity is used to manufacture hydrogen and hydrogen is being used to generate electricity. So definitely it is going to be costly than the actual electricity. Hydrogen should not be used to generate electricity exactly for this reason. Currently, the turbine technology can handle between 5 to 20% blending in the methane itself. With latest technology, this blending can go maximum up to 30%. That means if there is a natural gas turbine which is using 100% natural gas, we can blend maximum 30% of hydrogen in it. Now, what is the benefit of using 30% blending of hydrogen in this natural gas turbine? Now we can reduce the carbon emission by just 13%, 13%, which is not attractive enough. Neither it pays back heavily. 20% blending of hydrogen in methane reduces only 6% carbon emission. Now this much carbon emission can be minimized just by handling the boiler efficiently and smartly by using 100% methane itself. So what is the point in blending hydrogen itself? There are not yet commercially available power plants that can burn 100% hydrogen. Burning hydrogen blended gas would increase nothing but NOx emissions, which are dangerous. Now, technically, this makes electrical generation not attractive. Commercially, if we really see, as I explained, that if electricity is the raw material for manufacturing hydrogen, hydrogen is being used to manufacture same raw material, that electricity is going to be definitely costly. And this is what we see, that conventional fossil hydrogen cost between 1.25 US dollar per kg to 2 US dollar per kg in United States itself, while green hydrogen costs between $2.5 per kg to $4.5 per kg. In electrical terms, typically if we really see that the hydrogen density, the energy density of hydrogen in terms of electricity is 33.6 kilowatt hours, and we can get maximum about 14 kilowatt hour per kg. And even if we assume that 17 kilowatt hours electricity generation per kg of green hydrogen, considering the cost of hydrogen as $2.5 per kg, hydrogen based electricity will cost 0.14 US dollar, that is 14 cents per kilowatt hour. 14 cents per kilowatt hour hydrogen electricity, compare that with 1.76 US cents per kilowatt hour solar renewable energy, constant cost for 25 years, called levelized cost of electricity. So 1.76 US cent per kWh for solar generation continuous for 25 years, and 14 US cents for hydrogen based electricity per kilowatt hour for this year. Next year it will increase. It is much more economical to use renewable energy as it is directly without converting into hydrogen. Now the problem is industry justifying these costs mainly because there are three sets of analysts. What they are saying, that green hydrogen can become cost competitive by 2030 as economies of scale drive down the cost of electrolyzer and the price of wind and solar power will continue to fall. So these are the predictions. That is why they are saying that initial cost may be more, but as we generate more and more hydrogen, the cost will reduce. But they are not stating that as the cost of renewable energy is going to be reduced, which itself is the raw material for hydrogen, how come hydrogen based electricity is going to be cheaper than the renewable electricity? Industry experts who are promoting hydrogen are simply giving a blatant logic also, and what they are saying that industry has been pushing for blue hydrogen development with the simple logic that invest in suboptimal hydrogen infrastructure today. That means not so safe, just working infrastructure without investing in much. That means carbon capture too may not be there. So just start manufacturing hydrogen, forgetting safety, cleanliness measure, so that industry will start generating profit and eventually will go on investing in modernizing the infrastructure. Now this is the blatant lie, but this is what they want to tell us. In reality, the cost of green hydrogen will decline based on advancements in electrolyzer technology and continued reduction in the cost of wind, solar power, and this is not based on grey or blue hydrogen development. This assumption too is wrong, because as I said, renewable energy cost is going to be decreased, which will be the raw material. So hydrogen based electricity will be costlier than renewable energy, which is quite obvious. Now, the another very important issue is that suppose we think of manufacturing hydrogen from electrolyzer. Is there enough water available? The calculation clearly shows that water based electrolysis, which is currently being considered for manufacturing hydrogen, it requires really very negligible amount of water. Typically 1 kg of green hydrogen through electrolysis, it requires 9 kg of water. The power plant would need additional water for cooling, which would increase the total water usage to 15 to 20 kg of water per kg of green hydrogen. So what it means that suppose you want to build a 288 megawatt power plant using 100% hydrogen, it will require equivalent of an Olympic size swimming pool of water every 12 hours. Okay, let me give you a clear perspective. Suppose we replace entire fossil fuel which is today available, or rather entire energy which is being used today, with 100% hydrogen, then today we require 2.3 gigatons of green hydrogen to create hydrogen economy. Remember this quantity, 2.3 gigatons. Now 2.3 gigatons of hydrogen per year requires 20.5 gigatons of water per year, which is equal to 20.5 billion meter cube of water per year. This much quantity of water is just 15 ppm, not even percent, 15 parts per million of fresh water available on earth. There is only 1% fresh water available on earth compared to all the water. Remaining 99% is sea water. So out of this 1% fresh water, whatever may be that quantity, just 15 parts per million of that fresh water is required to create 2.3 gigatons of hydrogen. So this is extremely negligible amount of water which requires, and this is a good part. Now suppose we use sea water. As I said, sea water availability on the earth is, out of total water available on the earth, 99% is saline water, that is sea water, 1% is fresh water. If we take sea water, then just 30 parts per billion, just 30 parts per billion of sea water is required to manufacture this much amount of hydrogen to sustain our economy. So this is a good part of water electrolysis to manufacture hydrogen, that we require extremely less amount of water. So availability of raw material water is not a issue. This is very important. Now people will ask that, are we going to use saline or salty water for electrolysis? No, it is always require pure H2O water, and that needs to be desalinated. So seawater must be desalinated to manufacture pure distilled water, which is the input for electrolyzer. So how the picture will look? The issue is that desalination plants are already working worldwide, typically in Middle East, Israel, water starving countries. And if we really see the latest installed plant at Israel, Ashkelon plant, the data is very encouraging. What it says that whatever is the input seawater, 50% of that comes as output clean water. One. So in order to manufacture clean water, we require first of all 50% clean water. That means double the amount of seawater is required, and water available is abundant compared to the requirement of electrolysis of the hydrogen economy. So water input is not an issue. The cost of cleaning the water is an issue, and that particular, it says that from the economic viewpoint, desalination by reverse osmosis would add energy cost of $0.53 per meter cube, which is nothing but $0.01, that is just 1 cent cost of hydrogen per kg. 1 cent per kg is the cost of electricity for cleaning the water itself. So even if we install a desalination plant with the help of reverse osmosis as the latest technology and we get clean water, still there is no issue for manufacturing hydrogen through electrolysis. What is currently happening that in US, as I said, that the cost of hydrogen is $2.5 per kg to $4.5 per kg, and with the help of electrolysis, industry experts and hydrogen industry has developed a mission. That mission is known as Mission 111 or 1.1.1. What it says that the mission statement is to make available 1 kg of green hydrogen at a price of $1 within 1 decade. So in coming 10 years, hydrogen supporters are planning that the cost of green hydrogen should be $1 per kg. I hope so. The question is not of the cost of hydrogen. The question is of the technical data which is provided in this presentation of mine, which doesn't make any cost of hydrogen viable. Now how that we can see in this particular next data sheet. This shows the various efficiencies of various processes. Now please check it carefully. First of all, renewable AC electricity should be available. Let us say there is 100 kilowatt hour of renewable AC energy is available. Now, which economy is good? Hydrogen economy or electron economy? So this is the comparison. Let us consider first hydrogen economy, in which 100 kilowatt hour of renewable AC electricity is going. Now, for electrolysis, we require AC to DC conversion. The process efficiency is 95%. So the output will be 95 units. These 95 units will be input to electrolysis. As on date, electrolysis process is 75% efficient. Theoretically, experts stated that the electrolysis efficiency can be 94.5%, but that is theoretical. Thermodynamics law, especially second law, will not allow to achieve that, and 75% is fairly good, and I don't expect any drastic increase in the efficiency of electrolysis in coming years. We'll talk about that at the end of this slide, but let us consider 75% as electrolysis efficiency, which makes 71 kWh at the end of electrolysis. Now there are two routes. When the hydrogen is generated, you can either compress it or liquefy it. So let us take compression route. Compression route is 80% efficient. So 71 kWh becomes 64 unit kWh. Then after compression, you are supposed to transport it to the desired location. The transportation efficiency is 80%, which will reduce this generated or available unit to 52 kilowatt hours. Then this pure hydrogen will be used in fuel cell. As on date, fuel cell, the maximum efficiency is 50%. And again here also it will not increase drastically in coming years. So the 51 kWh input to the fuel cell, energy output will be 26 kWh. And then fuel cell will generate electricity, and this electricity will be given to the electric vehicle, where the efficiency of the electrical part is 90%. So at the end, 23 kWh electricity will be given to the vehicle. Utilize electricity by hydrogen or utilize energy by hydrogen is 23 kWh. So 100 kWh input will ultimately give you 23 kWh output. That makes input output efficiency of hydrogen compression route just 23%. Even if you increase efficiency of electrolyzer and fuel cell, because compression and transportation efficiencies are fixed, those are already established. So whatever may be your increase in electrolysis efficiency and fuel cell efficiency, 23% may go how far? Maybe 26, let us say 30%. So in this route, 70% is the loss of energy by using hydrogen itself. Is it really wise to use hydrogen to drive electrical vehicle, to drive vehicle? That is the question. Now, let us take liquefaction route. Instead of compression, suppose after getting hydrogen from electrolysis, you liquefy it. There you lose the efficiency of liquefaction itself is just 65%, and here you get 46 kWh as output. Transportation takes 90%, which makes available 42 kilowatt hour. These 42 kilowatt hour energy goes in fuel cell of 50% efficiency and comes out as 21 kWh, and then this kWh 21 kWh electricity will drive your electric vehicle with an efficiency of 90%. The output will be 19 kWh. That means not even 20%. So hydrogen economy, the efficiency for driving any vehicle will not go beyond 30%. The typical figure are 19% and 23% only. How far you can take it? Is it really worth manufacturing dirty hydrogen? Process is dirty, hydrogen itself is not so green. Transportation by pipe or by compressed cylinder itself is difficult. Using the efficient route, electrolyzer itself is not giving you an attractive efficiency. And if you are going to waste more than 70% of the input energy, why are you considering that as an economy or economic driver at all? We are chasing a mirage in the form of hydrogen, nothing else. Now consider electron economy, in which 100 kWh with the same 90% efficiency getting converted into AC via grid transmission, because here the loss is 10%. So 90 kWh, then AC-DC conversion and battery charging will be 85%. You are getting battery charging efficiency 85%, even 90%. So here 77 kWh electricity is already available to power the drive, and this electric vehicle with regenerative braking you can get 69 kWh. That means almost 70% efficiency of electric drive versus 30% efficiency of hydrogen drive. Which is better? You only decide. The eternal truth these facts cannot be changed with improvements in technology, because I am talking about technologies which are already established, and how far there will be improvement in those technologies. That itself is the issue. Now, if we really see how the industry is going to take a shape, that is again very, very important. Now, considering this, if we want to conclude this, then the conclusion is hydrogen economy is a wasteful economy. More energy is needed to isolate hydrogen from natural compound than can ever be recovered for its use. Making the new chemical energy carrier from natural gas would not make sense, as it would increase the gas consumption and emission of CO2. Instead, dwindling fossil fuel reserve must be replaced by energy from renewable sources. Advantages of hydrogen praised by journalists are misleading actually. The production of hydrogen depends on availability of energy and water, and energy itself is becoming very rare, though water is abundant for hydrogen economy. Electron economy is better than hydrogen economy. 80% more renewable energy is required to offset equivalent amount of electricity if we go for hydrogen economy. That means wastage is 70 to 80%. We recover not so good energy to convert the same back to electricity. Now this is very important. As I said, you are using efficiently generated renewable energy. Instead of using it directly, you are converting it into polluting hydrogen. That hydrogen itself is going to be inefficient up to its final stage, and we are going to generate, or we are going to use not so great energy in the form of hydrogen. Does it make any point? About 4 or 5 renewable power plants had to be erected to deliver the output of one plant to stationary or mobile consumer via hydrogen and fuel cell. This shows that if we put 100 megawatt renewable energy plant, the output in the form of hydrogen energy will be equivalent to 20 megawatt only. Rest 70 to 80 megawatt will go for all parasitic losses of hydrogen economy. Renewable energy should be directly used whenever it is possible, and hydrogen should not be used as a fuel, or hydrogen manufacturing base should not be expanded to justify the investment at all. Now, output input efficiency of hydrogen economy cannot be above 25 to 30%, while that of electron economy it is 70 to 80%. Hydrogen should not be used to power most vehicle. You can see that there are 20,000 hydrogen powered vehicles, but there are 20 million electrically powered vehicles globally. So you can see that electrically driven vehicles are more popular. Hydrogen is difficult to transport, it is difficult to compress and store in cylinder, it is not efficient and suitable for building and space heating, neither suitable for electricity and thermal application. Hydrogen blending doesn't make sense. Hydrogen is not better than renewable energy. Carbon capture is going to be myth. Since last 60 years, hydrogen is touted as future fuel, and it will remain so for another 100 years and next to that. Who knows? So, the important matter here is affected efficiency of hydrogen economy is because of wasteful conversion from physical to chemical and again chemical to physical processes. There are too many processes which are involved, and energy is getting converted from one to other many times. That is where losses happen. Hydrogen economy is based on two such wasteful conversion. One is electrolysis and another is fuel cell. So, however, hydrogen should never be used to justify expansion of fossil fuel infrastructure like oil refineries. That means currently whatever are the usages of hydrogen as a chemical, only they should be justified, and one should manufacture hydrogen only to that extent for using it as chemical, not as energy. In sustainable energy future, electricity will become the prime energy carrier. We now have to focus our research on electricity storage and modernization of existing electricity infrastructure instead of hydrogen manufacturing, transporting, and all those processes and technologies. Now, whatever may be the case, there are some usages of green hydrogen, and those are: green hydrogen have potential use as a long-term energy storage option, because renewable energy requires energy storage, and instead of wasting it all, at least store it in the form of hydrogen, and hydrogen will give it back. It will be lesser than what exactly energy was, but at least it will be more than not having energy at all. It could be produced during periods of excess renewable, otherwise wasted, and then you can use it back to balance the grid. Green hydrogen can complement batteries as CO2 free way to replace gas peaking plants, while reducing fracking and methane emissions that come from production and transportation of gas. So stored hydrogen can be used to generate electricity instead of using methane, which creates a lot of pollution for generating electricity. That it means we can use high heat industrial processes that cannot otherwise be electrified. There are many industrial processes where electrification is not possible, so high heat is required, and that is where hydrogen can be used as energy. Now, for shipping and aviation, possibly hydrogen may be a good fuel up to certain extent. Then we can use it as an energy feedstock for some industrial process for steel production. H2 can be used as chemical for reduction of iron oxide to recover iron, which saves 7% of CO2 emissions globally. Every iron infrastructure eventually rusts. Rusting is nothing but oxidation, and opposite of oxidation is nothing but reduction. This reduction can be done with the help of hydrogen to claim the clean steel back, and this is where we can save 7% of CO2 emission itself. Now, there are some ways in which green hydrogen use could be part of zero emission economy, and like we discussed, as a chemical or as an intermittent energy in industry itself, and green hydrogen is welcome for use as chemical itself. So that is where it is having maximum usage. Now, there are some grave concerns. Whatever I have stated just now, explained to you all, do you think it is a first time research done by somebody and that is me? No, this is all available. I just studied it and offered it to you in a perspective. What it means that there are people, there are governments, shadow government, they know all these things. They don't require yours and mine teaching. They know all these things. In spite of that, they want to develop hydrogen economy, mainly because of course, the reason is longevity of petrochem lobby, and there are various other agendas to promote the hydrogen economy. As a result, there are certain things which are happening, that huge sums of money were committed too soon. Even good scientists are touting for it without knowing much or knowingly, just because they want to market hydrogen economy for getting their funding. However, laws of physics, thermodynamics, they will not change, and ultimately this entire economy of hydrogen will prove itself unsustainable and wasteful. In the marketplace, hydrogen would have to compete with its own source of energy, and how far it will justify. Hydrogen is not a source of energy, but it's only a carrier of energy. At And this is how we must understand that hydrogen is certainly not going to be a future source of energy. Earlier we understand, the better. Again, I stated this is all known, but still things are happening. Why? So, here is my analysis. I'll again show you the hydrogen color code chart. Now, study it not from the point of view of color code, but give your attention to the process. If you see in this hydrogen color code chart, you will see that processes emitting CO2 and requiring carbon capture shall not be adopted, because those are polluting and those require much more energy as well as money for carbon capture, and those are not attractive. So, those will not be adopted. Costly and scarce feedstock like methane or fossil fuel shall not be consumed. So, those processes where methane, coal, oil are required, those processes will not be adopted. Water is abundantly available, and water as feedstock shall be the prime source available abundantly and cheaply, and that is why out of this 10 only electrolysis process will be focused by the global lobby for manufacturing hydrogen. Renewable energy powered process shall be preferred. This is because again carbon capture requirement is not expected. So what will happen, that only those processes where renewable energy electrolysis is there, those will be adopted, and ultimately those investors will come to know that renewable energy is not available 24/7, so they will adopt nuclear energy. So ultimately the winning combination will be nuclear energy powered electrolysis process. I hope you understand what I mean to say. Green hydrogen storage for enhancing availability of renewable energy will not be adequate, which is obvious. So nuclear energy will come as a rescuer, and this is nothing but rise of nuclear energy back again with hydrogen economy. Fukushima disaster pushed all nuclear power plants or plans to develop nuclear power projects worldwide were stopped since 2011. Somebody wants to bring it back, and this is where there is a place for nuclear energy. That is because contribution of nuclear energy for carbon emission is negligible or nil, and it is available 24/7, and electrolysis is of course generates no CO2. So as I said, electrolysis powered by nuclear energy shall be the ultimate winning combination, and that may be the reason for bringing hydrogen economy. Now if this is the future which I am predicting, then again see how the things will get changed. There will be contradictory developments, like petroleum lobby who wanted to promote themselves shall be left unattended. Nobody requires methane, nobody requires coal, oil to manufacture hydrogen, only water is required. So the petroleum lobby who actually decided to bring hydrogen economy will be sidetracked. Renewable energy will face competition from nuclear energy, mainly because renewable energy is not available 24/7. That is the first reason. Renewable energy cannot generate heat. Nuclear energy can offer heat as well as electricity, and like renewable energy, nuclear energy will not generate CO2. So nuclear energy is going to come. Renewable energy is required for common man for their electricity, but certainly not for hydrogen economy. Energy storage shall gain importance. Anyhow, in whatever way, energy storage is going to be a next line of business. And of course, this is going to be a rise of nuclear energy on global map. So this is what I am predicting. Now here, what are the business opportunities? Cost competitive and safe nuclear energy technology, development of high efficiency electrolyzer, that is going to be a new business, development of high efficiency fuel cells, that may be a business, and high density high efficiency energy storage technology, that will be the real business. So in a nutshell, this is the hydrogen economy picture as I see sitting here today about the future. News, or rather various newses which are coming are like this, that Indian government is planning 3.5 billion tons of hydrogen manufacturing via green route. Current price of hydrogen in India is Indian rupees 300 per kg, and government is going to give Indian rupees 30 per kg as a subsidy. So the manufacturing cost is 300 rupees a kg. It will be giving a guarantee of 10% profit to the manufacturer. Eventually the subsidy is going to be decreased as the scale of economies and cost reduction will improve. But India is promoting hydrogen to that level. There is a news from Netherlands where government of Netherlands declared euro 30 billion fund for truckers, and they said they can put orders for hydrogen or electric trucks to reduce the emission. They were expecting heavy rush from hydrogen truck requirement, but the fact is not a single consumer registered a request to purchase hydrogen powered truck. They received 1600 requests for purchasing total 1600 trucks. The plan was enough to supply only 400 trucks. So there is 4 times demand than what was expected, and everybody asked only for electric trucks. When truckers were asked reason, they said the capital cost of electric truck is lower than that of hydrogen truck. Operating expenses are definitely lower, and of course the charging points are more. It seems that consumers are interested in electric vehicles, that is electric economy or electron economy, but authorities are interested in pushing hydrogen economy. Government said that we do not have enough hydrogen fuel stations, that is why demand is less, but apparently that may not be the reason. North American Council for Freight Efficiency said that when we increase the number of fueling station for filling hydrogen, possibly truckers will ultimately switch to hydrogen. Let us see what is going to be the reality. So this was the second news. Third news, Japan declared that they will install all kind of infrastructure for hydrogen economy, and they fell flat. They could not able to develop the infrastructure suitable for hydrogen economy. They hurriedly declared after Fukushima disaster that we will not do any nuclear generation and will bring hydrogen economy, but now they are saying that whatever we are doing is not enough and adequate, and they said we failed to bring hydrogen economy. There were not enough infrastructure, there is not enough infrastructure. They could not able to manufacture and install electrolyzers, and that is what the news coming from a progressive country like Japan. So things seems to be not so good for hydrogen economy. Authorities are interested in pushing the hydrogen economy. Consumers are interested directly or indirectly in electron economy. As I said, biofuels are really suitable for automobiles. Electric economy is good for battery operated bicycles and tricycles, and hydrogen economy can wait till we take entire benefit of biofuel and electric economy. Till that time, wait and watch. Let us see who wins. Namaste.